Welcome back to this masterclass for actuarial students. So in the previous video, we looked at the theoretical principles that underpin bonds. So in this video, I would like to build on that theory and show you some examples of how these concepts apply in practice. So looking at this particular example, a zero coupon bond is currently trading at $50,000 on the bond exchange. The bond has a nominal value of $150,000. Now it asks us to calculate the yield if the bond is redeemable at par in 10 years' time. Now you can see why getting to grips with the terminology is essential if you're going to be answering these questions. We know that the term zero coupon bond means that there are no coupons payable or interest payments payable on this bond. The only payment that will follow is the redemption value or the repayment value. Now we also know that the redemption value or the repayment value is not necessarily equal to the face value. We need to find out what the redemption payment is. The key word here is redeemable at par. If you remember, par value is just another name for nominal value or the face value of the bond, which is $150,000. So because the bond is redeemable at par, we know that the repayment value is $150,000 in this case. Now finally, we know that the yield of the bond is the interest rate that will satisfy the present value equation of the bond when we calculate the price. So we know that the price the investor is willing to pay for the bond will just be the present value of the payments that we receive, which is only the redemption value of 150,000, discounted by 1 plus the yield. Remember, the yield is unknown because we have to calculate that yield, and we need to know the term of the bond, which is 10 years, so that will be to the power minus 10. So all we need to do is to solve for I. To do this, we need to recap some of the fundamentals of exponents. Now, when we have an equation such as x to the power 3 is equal to 9, we can solve the equation by manipulating the exponent of x. Now, if I raise both sides of this equation to the power 1/3, we know that we can calculate the new exponent for x by multiplying the two numbers 3 and 1/3. 3 divided by 3 is just 1, so that leaves us with x is equal to 9 to the power 1/3. Now we've changed the exponent of x from a 3 to a 1, and that's how we solve for x in these examples. We can rewrite this as price over 150,000 equals 1 plus I to the power negative 10. Now you can think of this 1 plus I as the x, and then we apply the principle that we have just learned. So we need this exponent to be 1 and not minus 10. So the question is, what number do we need to multiply by minus 10 in order to get 1? This is not difficult to do. You need to remember that minus 10 can be written as a fraction minus 10 over 1. Now what we do to calculate this unknown number is to flip the equation. So that will be minus 1 divided by 10. So we swap the numerator and the denominator. And as you can see, the sign of this new number will be a plus because a minus and a minus is a plus. 10 divided by 10 is just equal to 1. So yes, indeed, we'll end up with an exponent of 1 if we raise this entire equation to the power minus 1 divided by 10. Of course, we need to do the same on the left-hand side. Now, if you look at this, the price of the bond is actually known. So P is known, and this has a value of 50,000. Okay, so the right-hand side of the equation then becomes 1 plus I to the power minus 10 multiplied by minus 1 over 10. And this is simply 1 plus I. So the exponent now becomes a 1, and then we can easily solve for I. You can calculate the left-hand side of the equation quite easily as 1.11612 with some decimals. And that leaves us with I is equal to 0.11612 or 11.6%.